Well, now that we know the center, or the expected value, we now need to find the standard deviation. So the standard deviation we've already learned about a little bit in the past, and we're going to compute that for the have a heart game just as we did expected value. It's important to understand that standard deviation is still the same concept. It's the spread of the data. So that is, of course, variance and standard deviation. Remember from when we learned this previously, variance would be this standard deviation squared. So we would take the square root of the variance in order to find the standard deviation. So of course I'm going to show you how to do this by hand, just as we did with expected value, and then I'm going to show you how to find both mean and standard deviation using your calculator and StatCrunch. So just as we did before, standard deviation or variance is first found by finding the variations from the mean, so our value that we have minus the mean, and then we're going to square those because that makes them positive, and then we're going to multiply them by the probability, and we're going to find all of the sum, and that's variance. So this doesn't really make sense until you actually do it. And then of course once we find the variance, we're going to take the square root to find the standard deviation. Recall previously that we just found the expected value and it was negative $1.35. That's our expectation each time we play. So there's two ways to do this. You can make a table or you can write it out just like this. I'm going to show you in the table first, then show you down here. So x is again our random variable, and these are the values that made up x, 95, 5, 0, and negative 5. We're going to take that value minus negative 135. So 95 minus the negative 135 is actually plus 135, so I get 96.35. From there, I'm going to square it. So I took this value and I squared it, and then I multiplied it by 1 out of 52 because that's what the probability was of getting that ace of hearts. And then that was my value. I repeated that process for the 5, for the 0, and for the negative 5. So this one, the probability was 3 out of 52 because it was the rest of the aces. So I multiplied those values to get this one. For this one, it was any other heart, so that was 12 out of 52. And then again for the last one, it was any other card, which I believe was 36 out of 52. And those were the values. So notice what I've done here is then I've just added up all of those to get my 190.5. That's my variance. This lesson, or this module, I guess, we're going to use variance more than we did before. Before we just talked about variance in terms of how to get to standard deviation. In this one we're actually going to do a few calculations with it. But that's how we found variance. And then of course to find the standard deviation, I just took the square root to get 13.8. Now, this week's case study, or this module's case study, you will have to do one of these by hand. This is probably the easier way to do it by hand. So again, let me show you what I'm doing. I'm taking the x value, which is 95. I'm subtracting negative 135, which we talked about before as plus, and I'm squaring it, and I'm taking it times 152. So that's everything I did here. I just did it all in one thing. Sorry about the error. This plus should be on this side of it. So I added all of those up to find the variance. Then I found the standard deviation by taking the square root of 190.5. So again, I could have written the little standard deviation sign there, but in general, I'm just going to write standard deviation x. So just a few things about standard deviation. Again, it's just a weighted average. It gives us a value or an idea about how spread out our values are going to be from the center, which of course is our expected value. So in our have a heart game, our center was negative 1.35, negative $1.35, meaning that you would lose $1.35 to me every single time you played. The standard deviation was 1380, which means, again, using that estimate of the empirical rule, that 68% of the time it would be within one standard deviation on each side. And so that would give me that with 68% of the time it would be between those two values.